Advanced Brake and Suspension Systems Introduction. Hello folks, welcome to this comprehensive lesson on advanced brake and suspension systems. In today's session, we will delve into the sophisticated components that comprise these critical automotive systems, explore their functions, and discuss essential repair and maintenance techniques. Understanding these systems is vital for ensuring vehicle safety, performance, and longevity. Advanced brake system components and functions. 1. Overview of brake systems. Brake systems have evolved significantly over the years, integrating advanced technologies to enhance vehicle control and safety. The primary purpose of a brake system is to decelerate or stop a moving vehicle. This is achieved by converting kinetic energy into heat through friction. Let's explore the key components of advanced brake systems and their functions. 2. Disc brakes. Disc brakes use a caliper to squeeze pairs of pads against a disc or rotor. This action creates friction that slows down the wheel's rotation. Modern vehicles often use vented rotors to dissipate heat more efficiently. Components, rotors, rotating discs connected to each wheel, providing the surface for pad friction. Calipers house the brake pads and pistons, responsible for pressing the pads against the rotor. Brake pads, made of friction material, press against the rotors to slow down the wheel. 3. Anti-lock braking system ABS. The ABS prevents wheels from locking up during intense braking, maintaining traction and steering control. Components, speed sensors, monitor wheel speed and inform the ABS controller. Pressure modulator modulates brake pressure to prevent wheel lockup. ABS controller manages the system's response based on sensor inputs. For electronic brake force distribution EBD. EBD optimizes brake force on each wheel based on load distribution, enhancing stability and stopping power. It works in conjunction with ABS. 5. Brake assist, also known as emergency brake assist. This system detects emergency braking and increases brake force if necessary to reduce stopping distance. Advanced suspension system components and functions. 1. Overview of suspension systems. Suspension systems are crucial for absorbing shocks from the road, maintaining tire contact, and ensuring driver comfort and vehicle stability. Let's examine the components of advanced suspension systems and their roles. 2. Coil spring and leaf spring. These are primary components responsible for absorbing road shocks. While coil springs are commonly used in cars, leaf springs are often found in trucks. 3. Shock absorbers and struts. Shock absorbers dampen the oscillation of springs, while struts combine a shock absorber with a coil spring in one unit, providing structural support to the suspension. 4. Air suspension. Air suspension systems use air springs instead of traditional steel springs, allowing for adjustable ride height and improved ride quality. 5. Active and adaptive suspension. These systems electronically adjust the damping forces in real time based on driving conditions, providing optimal comfort and handling. Repair and maintenance techniques for advanced brake and suspension systems. 1. Regular inspection, routine inspection of brake pads, rotors, calipers, and fluid levels is crucial. Check for wear, cracks, and leaks. 2. Replacing worn components. Replace brake pads and rotors when they reach minimum thickness specifications. Use high-quality parts to ensure reliability. 3. Brake fluid maintenance. Regularly check brake fluid levels and replace contaminated fluid. Ensure the system is free from air bubbles by bleeding the brakes properly. Repair and maintenance techniques for advanced suspension systems. 1. Inspecting suspension components. Check for worn bushings, ball joints, and tie rods. Listen for unusual noises and observe vehicle alignment. 2. Replacing shock absorbers. Replace shock absorbers and struts if they are leaking or provide inadequate damping. This ensures optimal ride quality and handling. 3. Maintaining air suspension systems. Inspect air springs for leaks and ensure the compressor is functioning correctly. Address the electronic faults promptly to prevent further issues. Executive summary. Advanced brake and suspension systems play a crucial role in enhancing vehicle safety, stability, and overall driving experience. Here's a summary of these systems. Advanced brake systems. 1. Anti-lock braking system ABS prevents wheel lockup during hard braking, maintaining traction and control. 2. Electronic stability control ESC helps stabilize the vehicle during loss of traction by applying brakes to individual wheels. 3. Traction Control System TCS regulates engine power and applies brakes to prevent wheel spin and loss of traction. 4. Regenerative braking captures kinetic energy during braking and converts it into electrical energy, improving fuel efficiency. 5. Autonomous emergency braking automatically applies brakes in emergency situations to prevent or mitigate collisions. Advanced suspension systems. 1. Electronic suspension control adjusts suspension stiffness and damping in real time to optimize ride comfort and handling. 2. Adaptive suspension automatically adjusts suspension settings based on driving conditions such as speed and road surface. 3. Air suspension uses compressed air to adjust ride height and stiffness, providing improved comfort and load carrying capacity. 4. Magnetic ride control employs magnetic fields to adjust suspension stiffness, offering improved ride comfort and handling. 5. Active roll control actively adjusts suspension to reduce body roll during cornering, enhancing stability and handling. Benefits and future directions. 1. Improved safety. Advanced brake and suspension systems enhance vehicle stability and control, reducing the risk of accidents. 2. Enhanced comfort. Adaptive suspension and advanced brake systems provide improved ride comfort and reduced driver fatigue. 3. Increased efficiency. Regenerative braking and advanced suspension systems can improve fuel efficiency and reduce emissions. 4. Integration with autonomous vehicles. Advanced brake and suspension systems will play a critical role in the development of autonomous vehicles, ensuring safe and stable operation. Advanced brake systems comprise various components that work together to provide safe and efficient braking performance. Here's a summary of key components and their functions. Mechanical components. 1. Brake pads, friction materials that contact the brake rotor to slow or stop the vehicle. 2. Brake rotors, metal discs that rotate with the wheels, providing a surface for brake pads to contact. 3. Brake calipers, housing that contains brake pads and applies pressure to the brake rotor. 4. Master cylinder converts non-hydraulic pressure from the brake pedal into hydraulic pressure. Electronic components. 1. Anti-lock braking system ABS module controls ABS function, preventing wheel lockup during hard braking. 2. Electronic stability control ESC module helps stabilize the vehicle during loss of traction. 3. Brake electronic control unit BECU manages brake system functions, including ABS and ESC. 4. Wheel speed sensors monitor wheel speed and provide data to the ABS and ESC modules. Hydraulic components. 1. Brake fluid transfers pressure from the master cylinder to the brake calipers. 2. Brake lines connects the master cylinder to the brake calipers, carrying brake fluid. 3. Brake hoses, flexible connections between brake lines and calipers. Advanced features. 1. Regenerative braking captures kinetic energy during braking and converts it into electrical energy. 2. Autonomous emergency braking automatically applies brakes in emergency situations. 3. Electronic brake force distribution EBD automatically adjusts brake force distribution between front and rear axles. These advanced brake system components work together to provide improved safety, efficiency, and driving experience. Repair and maintenance techniques for advanced brake and suspension systems require specialized knowledge and tools. Here's a summary of key techniques. Brake system techniques. 1. bleeding and flushing, removing air and old brake fluid to ensure proper system function. 2. Pad and rotor replacement, replacing worn brake pads and rotors to maintain proper braking performance. 3. Caliper repair and replacement, repairing or replacing brake calipers to ensure proper brake application. For ABS and ESC system diagnosis, using specialized tools to diagnose and repair issues with advanced brake systems. 5. Regenerative braking system maintenance, maintaining and repairing regenerative braking systems to ensure proper function. Suspension system techniques. 1. Wheel alignment, adjusting wheel alignment to ensure proper tire wear and vehicle handling. 2. Shock and strut replacement, replacing worn shock absorbers and struts to maintain proper ride comfort and handling. 3. Spring replacement, replacing worn or damaged springs to maintain proper vehicle ride height and handling. For electronic suspension system diagnosis, using specialized tools to diagnose and repair issues with advanced suspension systems. 5. Bushings and mounts replacement, replacing worn or damaged bushings and mounts to maintain proper suspension system function.
General techniques. 1. Visual inspection, visually inspecting brake and suspension components to identify wear or damage. 2. Testing and diagnosis, using specialized tools to diagnose and repair issues with advanced brake and suspension systems. 3. Documentation and record keeping, maintaining accurate records of repairs and maintenance to ensure warranty validity and future reference. 4. Safety procedures, following proper safety procedures when working with brake and suspension systems to prevent injury or damage. 5. Manufacturer-specific training, completing manufacturer-specific training programs to stay up to date with the latest repair and maintenance techniques. Conclusion and conclusion. Understanding advanced brake and suspension systems is essential for ensuring vehicle safety, performance, and comfort. Regular maintenance and timely repairs not only prolong the lifespan of these systems, but also enhance overall driving experience. Through this lesson, we hope you have gained valuable insights into the complex yet fascinating world of modern automotive technology. Keep exploring and learning to stay ahead in this dynamic field. Thank you for attending this lesson. See you in the next lesson. Happy learning, folks.